34.5 deals with limits of accuracy. If I want to measure, say for example, the length of this graphics tablet here with a ruler, and I can judge it well to within 1 centimetre, let's say it comes to, I don't know, I measure it as, just doing a visual thing now, I'm measuring it as 35 centimetres, say, approximately. Now, question is, how low can you go and still call it 35 centimetres? Answer, 34.5, because you know the rules, 5 or more push it up. So that will push the 4 up to 5. Now, how high can you go and still call it 35? Answer, 35.4999999, 34.49 recurring. In other words, we have to approximate that to 35.5 centimetres. Now, many of you will argue, say, well, actually, sir, 35.5, you've got to call it 36, so you're wrong. I know that because actually the lower bound, let's just try and get this pen to go properly, bound, B-O-U-N-D, yeah, the lower bound for a measurement of 35 centimetres will be half a unit below 35, which is 34.5, and the upper bound, which is this one, will be half a centimetre above the 35. But we're not actually allowed to be 35.5. We're allowed to be 35.49 recurring. So, but for calculation purposes, this is identical to that, because by the time you go to all those 0.9 recurrings, you might as well call it 0.5. Alright, so don't any more arguments about this one. Alright, if I jump to question 3, this is George talking, real questions now, page 200. George measured the length of a post for a washing line in his garden. He found it was 3 metres to the nearest metre. So I've got 3 metres now. It's the nearest metre. So metre, you know, is huge. If I stand back here, here's a metre. What are the smallest and largest possible length of the post? Well, if we hold metres, we can be as low as half a metre smaller, so that's 2.5 metres, or half a metre above, 3.5 metres. Okay, so that'll be the smallest, using the words from the question, and this will be the largest possible length. Look a bit more like an M. Alright, that's George. Blah-de, blah-de, blah, too much to read there. Yeah, let's do question 5. Why not? Mike measured the distance from his home to Windermere to his school in Kendal. So, his home is in Windermere. I don't know if that's near, I haven't got a clue. He found it was 18 kilometres to the nearest kilometre. What is the smallest distance that Mike's measurements could be? How low can you go? Answer, 17.5 kilometres. You can still call it 18. And what is the largest distance that Mike's measurement could be? Answer, 18.5 kilometres. Alright, so that's the smallest distance from school, and that's the largest distance from school. Question 6. The weight of a letter is 43 grams. To the nearest whole gram, what is the smallest and largest values for the weight of the letter? Well, least value, 42.5 grams. You getting this now? Upper bound, 43.5 grams. Least, greatest. Right, let's just take a look at question 7, because I've got time to do this. A bridge has a sign stating the maximum weight allowed on it is 2 tons. Right, so 2 T's. A van driver knows his van weighs 2 tons to the nearest ton. Can the van driver be sure that it is safe for him to drive over the bridge and give a reason? Well, if he's saying it's 2 tons to the nearest ton, he could be as low as 1.5 tons, which is completely safe, or he could be as big as 2.5 tons, which is very, very unsafe. So the answer is, can he drive safely over the bridge? Not safe, because the van could weigh, please underline that, could weigh, I've lost the question now. to 2.5 tons. So no, he can't do that. Turn over to the lovely question about Rachel and her school bag. Right, here's Rachel. Rachel weighs the books in her school bag. Her textbooks altogether weigh 3 kilograms to the nearest kilogram. Right? Maybe she's using kitchen scales that have only got, have only got whole kilograms on them. Unlikely, but we have to assume something like that. And all her exercise books weigh 1 kilogram. Right. There are no other books in her bag and there's nothing else. What is the maximum weight of books in her bag? Well, let's just go for the maximum. That could be as big as 3.5 kilograms. That could be as big as 1.5 kilograms. Yes, half a kilogram either way. So it could be as low as 0.5, as big as 1.5. If you're working to the nearest kilogram, that is the upper bound possible for each part. Add both the bits. I've got 5 kilograms is the maximum weight it could be if she's out by the maximum amount. So up to 5 kilograms. That's it. Shall I try number 10? May as well. It's one of these little starry ones that involve you thinking a little bit. Mark buys some food from the grocery shop. He buys 1 kilogram of carrots. Right, 1 kilogram of carrots. He buys 5 kilograms of, don't know yet, potatoes. Both weighed to the nearest kilogram. What is the minimum possible weight of shopping? The smallest values. Well, that's going to be 0.5 minimum, because 0.5 can still be rounded up to 1. And the 5 kilogram minimum, well, that's going to be 4.5 kilograms, because that can still be rounded up to 5. And what is the total weight? If the minimum possible weight will be these two minimums, these two lower bounds added together, a half plus 4.5, 5 kilograms. That's the minimum he's going to walk away with. And I think you've got the idea about upper and lower bounds. Not used in calculations, that's for grade A. In terms of accuracy, you've got a lower bound, the smallest possible value, and the upper bound, the biggest possible value, depending on the accuracy that you're measuring to. But certainly up to grade C, you're looking at what happens to a whole unit. Answer, it drops half a unit either way, above or below the one that's in the middle. And that's the conclusion to that, and that's 12.5 finished.